Unraveling the mystery of white holes. Greetings, fellow space enthusiasts. Today we'll be diving deep into one of the biggest mysteries in astrophysics, the theoretical concept of white holes. As the photonegative twins of black holes, these ultra-bright objects that eject mass and energy have captured the imagination of physicists and sci-fi fans alike. But could they actually exist in our universe? What astonishing secrets might they reveal about space and time if discovered? Let's unravel this cosmic enigma together. I'm Dr. D, and I'll be your friendly guide on this adventure into cutting-edge physics. We'll start by reviewing what we know about black holes, since white holes are hypothesized to be their partners in space and time. Then we'll introduce the wild ideas around white holes themselves, from what happens at their dazzling surface to whether we'll ever find real examples out in the depths of the cosmos. Sound exciting? Then let's begin. Chapter 1. Understanding black holes. What are black holes? We can't talk about white holes without first understanding what black holes are all about. Simply put, black holes are formed when massive stars collapse at the end of their life cycle. The gravity of these dense stellar remnants is so ridiculously strong that even light itself cannot escape across their border, known as the event horizon. Once matter or energy crosses this threshold, it's essentially cut off from the rest of our universe. No information can ever get out. The mass of black holes is concentrated into an infinitely tiny point called a singularity, so they continue to influence the motion of objects and warp space-time around them with their substantial gravitational effects. Properties of black holes. What defines a black hole, then? They have only three major properties: mass, electric charge, and rotation or spin. But out of these three features, the most important one is their mass, which determines the strength of their gravitational pull. More massive black holes have a larger event horizon too. Within their boundary, the laws of physics as we know them break down at the central singularity. It's an extremely bizarre realm that we can't yet fully describe with our current scientific models. Unlocking the mysteries of these monster gravity wells remains an exciting open frontier in astrophysics and quantum gravity. Mysteries yet to unravel. Many perplexing questions remain about the enigmatic nature of black holes. What happens to information that crosses the event horizon? How do quantum effects come into play in their chaotic interiors? Do they connect far-flung parts of space-time through passages like wormholes? This is all fertile ground for cutting-edge researchers around the world. And some believe that hypothetical white holes potentially linked to black holes could provide clues to resolving these mysteries, which is why we cosmic adventurers eagerly seek them out. The answers we uncover may fundamentally transform comprehension of the very fabric of the cosmos. Let's find out. Chapter 2. Introducing white holes. Theoretical counterparts to black holes. Now that we have better context on what black holes are, let's introduce their hypothetical twins, white holes. Instead of gravitationally pulling material inward like their darker partners, white holes are predicted to violently eject mass and energy outward. This could happen because they may be linked to black holes through Einstein's equations, perhaps serving as their exits into another domain. The possible origins of white holes are still speculative, but of great interest for theorists exploring the quantum nature of black hole event horizons and interiors. How could these objects connect regions of our universe through space-time conduits? The mysteries multiply, which is part of the fun for physics adventurers like us. What happens at the event horizon? If white holes exist, their event horizons should exhibit mind-bending phenomena. As matter and radiation plunge inward on the black hole side, perhaps space-time curvature allows it to burst forth with incredible brightness from a connected white hole somewhere else entirely. The details of how energy, information, and quantum effects operate in this process raises paradoxes that have had physicists scratching their heads for decades. What happens in black hole interiors once you pass the event horizon? Could white holes hold clues to resolving these conundrums at the very boundaries of cosmic comprehension? Our galaxy may contain billion-year-old white holes that offer passage to far reaches barely imagined. Conditions for stability. For white holes to remain stable for any significant period, physicists hypothesize they require very special environmental conditions. They likely need rapid rotation to counteract the outward pressure of matter and energy escaping. Accretion disks that feed the mass could also contribute to sustaining these dazzling gushes. And perfectly symmetrical jets shooting perpendicular to the accretion flow may prevent blowback from disrupting the integrity of white holes. Of course, these criteria could make white holes very rare in the universe if they exist at all. But the fact that they arise plausibly from general relativity equations keeps hope alive that we may find them twinkling in the cosmos someday. What revelations about reality might they offer if so? The quest continues. Chapter 3. Searching for white holes. Have we found any white holes? The next obvious question: have astronomers actually observed any definitive white hole candidates yet? So far the answer is no. But we have detected strange gamma-ray bursts and other unusual cosmic events that could suggest ultra-bright, compact objects ejecting matter and radiation violently. As our instruments and models improve, perhaps we'll have better luck spotting signatures of these dazzling space-time geysers. What to look for in observations? When gazing into the infinite blackness punctuated by stars, galaxies, and nebulas, what exactly should we be searching for? Rapid jets of particles and heat blasting outward could indicate a white hole violently expelling material and energy. Brighter than supernovas and quickly changing in luminosity over hours or days are other possible observable features. Flickering patterns that don't match models of known phenomena may provide clues as well. And white holes may often be tethered to black holes or dense neutron stars based on theoretical predictions. So fellow star voyagers, keep your telescopes peered toward the darkness in hope of finding a glowing cosmic fountain, defying gravity and perhaps time itself. Advances making detection more likely. With next-generation telescopes like the James Webb Space Telescope conducting deep scans of the infrared sky, chances are improving that we may finally capture evidence of white holes. Sophisticated computer simulations can also better predict what observational data should look like. As the amount of information streaming in increases exponentially, advanced algorithms leveraging machine learning may recognize anomalies that reveal white holes' signatures. Perhaps one day soon, breaking discoveries will shock the scientific community and shift our very sense of reality's very fabric. Will we find flickering patterns linked to gamma-ray bursts that confirm white holes' existence? The breathtaking possibilities send tingles down this physicist's spine, even imagining it. Our adventure into the astounding possibilities of white holes has led us on quite a ride. We've explored how these ultra-bright inversions of black holes could unlock secrets of nature we've only started to grasp at. From their event horizons busting with energy to hidden connections tying space and time into knots, they offer profound questions we yearn to answer. While no definitive examples have been confirmed so far, the theoretical foundation and wide-eyed curiosity remain stronger than ever. As both physics and astronomy advance hand in hand, we come closer to probing space-time domains once considered forever inaccessible. What astonishments await out there among the stars? Let's find out together. I hope you've enjoyed pondering the mysteries of our universe with me today. Until our next cosmic chat, this is Dr. D signing off. Stay curious, explorers, and keep gazing up. The grandest show around is always right over our heads in the eternal night sky above. Thanks for joining me on this imaginative journey into the world of white holes. I had a blast sharing my passion for physics and astronomy with you all. Let me know in the comments what other weird cosmic objects or topics you want us to cover next. And if you spot anything unusual as you scan the starry skies that could suggest white holes, be sure to pass it my way in the comments section below. I'd love to check out any strange observations. Stay stellar out there and keep searching. Our universe is full of astonishing mysteries awaiting revelation by intrepid adventurers like you.